looking at my formula sheet the other day, and I saw this thing called the law of sines. Oh yeah, you don't want to break the law. Breaking the law! Breaking the law. You don't want to break the law of sines. What in the world is the law of sines? And how do I break it? Because I'm a kid. I want to break some laws. No, you don't. I'm going to show you the law of sines in action. And how do you use it and what kind of problems you'll be asked. Why? Because we math teachers love to ask obscure, wild, crazy questions. And once again, there we go. Let's see if I can get this working again. There we go. So, solving triangles with sine notes. Well, really I should have written the law of sines, because that's what we're going to learn. So let's take a little gander back into the initial trigonometry that you learned. You learned that if you are given a right triangle where you have a hypotenuse, and we call the side opposite the angle the opposite side, and we call the side next to it the adjacent side, and we go through this long drawn-out thing some of your teachers like to use, so, ka, toa, huya, suka, toa. Not my favorite. Whatever. Let's get rid of it. Not my favorite. I like the one I learned from way back when I was in high school. I learned this in 1985. Oh, man. That's like before your parents were born, probably. Well, maybe not. I learned that sine of an angle, is equal to opposite over hypotenuse. And I learned that cosine of an angle is equal to adjacent over hypotenuse. And I learned that tangent of an angle is equal to opposite over adjacent. And the acronym, or the fun thing that I learned, was some old horse caught another horse taking oats away. It has stuck with me for like, I don't know, what is it, like 30-something years, a little over 30 years now. Woo-hoo-hoo! No wonder I don't have any hair. Man. Modern times, some old hippie caught another hippie tripping on acid, some old, never mind. I'm not going to get to all the ones we've come up with. You decide. I know you've learned it. I don't need all this. We've learned this. We've got this. We've got this down. We know how to do right triangles. It's not a problem. If I wanted to find that hypotenuse, I would do sine of 63 is equal to opposite over hypotenuse. 8.9 over whatever the hypotenuse is. I would cross multiply. H times sine of 63 is equal to 8.9. I would divide by sine of 63. And I would get some number. Boom, bam, there, gotcha, not a problem. If I wanted to find the adjacent side, I'd use tangent. Opposite over adjacent. I am not going to belabor that point. That's not what we're here to discuss. We're here to discuss, bam, that thing. What is that thing? That's not a right triangle. It's not going to work. Let me label it. Capital A, capital B, capital C. We are going to use a well-defined law in mathematics. I don't know if it's really called a law. It seems kind of strange. Law. Breaking the law. It's something we're going to use. And what it is, and what it states is that the ratio of any side to its angle is equal to any side to it. The sine of its angle is ratio of any side to its sine of its angle. And we'll use that interchangeably. So A over sine A is equal to whatever that ratio is equal to B over the sine of its angle, which is equal to C over the sine of its angle. Now, for those of you that are very curious, I am certain that you could do a Google research and Google blah, 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 and find out why that works. This ain't going to be that place. This is where we learn how to utilize that well-defined statement right there. And what we are going to do is, no, we're not going to use three sides. What it says is any two sides and any two angles, so I can pick them. The key is to solving these, you need to have 3 of 4. you need to have only one of these missing. So let's say I decided to use A and sine A and C and sine C. I need 3 of the 4 in order to solve. Let's see how it works in play, in reality. These directions say find R. By the way, did I ever tell you? No. So this was a funny commercial. It says the directions here are find R. You know, if the directions was, you have to be very specific now, because this one kid said, there it is. There it is. Clearly not a very good Algebra 2 student. We're going to use the law of sine. So R over the sine of R, which is 73, is equal to 54 over the sine of 18. So there's 18 and its side opposite, and there's R and its side opposite, or angle opposite, excuse me. So that's what we're going to use. Cross multiply. Boom. It's not very difficult. The law of sines is not a very difficult thing to use. So we're going to do R times sine. I don't know why I wrote an 8. R times sine of, I wish I could use the back end of this thing as a reason. Let me see. Nope, doesn't erase. Ridiculous. I'm going to have to figure it out. I bet there's an easy way to do it. R times sine of 18, because we're going to multiply those two together, is equal to 54 times the sine of 73. Now I want R by itself, so I'm going to divide by sine of 18. Divide by sine of 18, divide by sine of 18. And there's nothing left over on that side except R. So whatever I get, that's R. Well, not doing this one in my head. 15 sine 73. So we'll do control division. 15 times the sine of 73 all over the sine of 18. And we hit enter, and I get 46.42. So 46.42. And that's all I'm going to write down now, because I know it said nearest integer right here. So R equals 46. Bam, done. Let's try to find E. Here's E. So I'm going to use 127. Let me pick a different color. 127 over the sine of capital E is equal to F over the sine of 45. And then I'm going to wait a second. What do we have here? Now, I just went through and said to you, we need 3 of 4. I don't have 3 or 4. I have 1, I have 2, but I have 2 missing things, and that's not acceptable. So either we can't do it, either I set up a crazy question, or there's something else I can do. And let me grab green. And that something else we can do is realize, oh yeah, that's 65, and that's 45. And 65 and 45 is 110, which leaves 70 degrees for E. So I shouldn't have put E in here. I should have put 70 degrees. And now I have 3 of the 4 things. So I'll do F times the sine of 70 equals 127 times the sine of 45 degrees. Sweet. Almost done. Divide by sine 70. Divide by sine 70. And I get, I have no idea, 127 sine 45. 127 times the sine of 45, which I just know is the square root of 2 over 2. You ought to know that too. Divided by the sine of 70 equals 95.56. Now I'm going to stop there because 95.56. I know it said nearest integer, so I know my answer is 96. So the law of sines, given any triangle, no longer do you have to use SOHCAHTOA. You can use the law of sines for any triangle to find either a given side or a given angle. So far, we've found a given side. Now we're going to use it to find a given angle. But you'll notice these directions are a little strange. Little bit strange here. What are we going to do? A little sustenance. Look, it's like 7:35. It's almost my bedtime. You see how bald I am? I'm an old guy. Us old people go to bed early. So let's see what we got here. Let's see what's weird. How many different triangles are possible? What? Isn't a triangle just a triangle? Well, before I get into this thing, let's talk a little bit. Let's look at triangles. This triangle is called an acute triangle. You might want to try to call it an equilateral triangle. It's pretty close. It's not bad. But it's acute. 3 angles less than 90 degrees. Let's say when I was doing my math and I found out that the sine of angle A, the sine of A was equal to 1/2. I'm just going to pick something we know. There's a lot of you that said, okay, A has to be 30 degrees. Okay, no problem. There it is, 30 degrees. And then these two could make up the other 150 degrees. But who's to say A is 30 degrees? Why are you the be-all, end-all of sine? Maybe sine doesn't want to be 1/2. Maybe you're not very smart. Don't yell at me, man. I don't know what I'm talking about. What are you talking about? No, seriously, think about it. Sine equals 1/2. We've learned this for now. We're at the end of this sine unit. We're there at the end. You should be a more critical thinker. What else or where else is sine 1/2? Well, if you go back to the fact that all students take calculus, and we know that sine is positive here and here, then we know that sine is positive or could be 1/2 at 30 degrees, or it could be 1/2 at 150 degrees. So you might think that it looks, and our triangle looks like this, but maybe our triangle looks more like this, where this is 150 degrees. You can't tell, and that's why the directions state, tell me how many triangles, how many different triangles can be formed. So that's what we're going to do. We're going to try to find out how many different angles can be formed, or triangles can be formed. Did anybody get scared when I yelled at you? I scare some people sometimes. It's the bald head. I don't know. It's a little intimidating. I'm not going to lie. I use it all the time. I scare people. So we're going to draw a triangle. A, B, C, and D. Now, it doesn't matter how I draw it. I know that this is going to require a lot of space, so that's too big. So let me draw a small triangle. Let me draw a little itsy bitsy triangle. A, B, C. I didn't leave a lot of room here for work, so little a is 20, little b is 11, and A is 115 degrees. So clearly we're going to be looking for angle B. So I'll do 11 over the sine of B equals 20 over the sine of 115. Okay, no problem. Grab a different color just to kind of make things fun and fancy. Oh, I don't know, it's kind of blue. So 11 times sine, oh, let's do this. 20 times sine of B equals 11 times the sine of 115. Now, I still got to get sine B by itself, so I'm going to get rid of this 20. Divide by 20. Divide by 20. And I get the sine of B equals 11 times the sine of 115 over 20. Now I need to solve for B. I need to get B all by itself. You can't divide by the word sine. We've done this a million times. In order to find an angle, you need to use the inverse trig function. And what you do is need to take the inverse or the arc sine of both sides. So I'm going to take the inverse of that side, and I'll take the inverse of this side. Well, this sine and this inverse, or arc sine and sine, cancel each other out. And so I get B equals, and if you put this in your calculator, I already know the answer to be 29.9 degrees. I've already done that problem enough. 29.9 degrees, which is approximately 30 degrees. Well, B can equal 30 degrees, or, and whenever you do these law of sine questions and it asks about triangles, you have to find the second quadrant angle as well. We have the reference angle of 30. That's in the first quadrant. I need to go to the second quadrant, just like I showed you a few minutes ago. So this could be 50 or 150. And now we have to test. Now we got a little work to do. It's not much. It's just a little bit of a test. I want to test to see how many triangles I can do. So I'm going to test for one triangle. My first triangle would be starting with the 115 degrees I was given. I'm going to add in the 30 degrees, or approximately 30 degrees I came up with, and I get plenty of angle left over so that I know I can get three angles that will add up to 180 degrees, because this is only 145. So that must mean this is somewhere around 35 degrees. Around. That leaves plenty of room. Or triangle 2. Let me test for a second triangle. Can there be two? 115 plus. Now my other possibility for theta was 150 degrees. So I'll add that 150 degrees in. And I look at this and I go, wait a second, I already have 265 degrees. And I still have a third angle to go. I'm way over. So it's not going to work. So believe it or not, all of this work to tell me, hey, you can only make one unique triangle. All right, let's do another example of the law of sines. Draw another little tiny triangle over here. Do this one. A, B, C. Little a is 13. Little b is 40. Measure of angle A is 40. What? No, measure of angle is 40. Little b is, what am I doing? Little b is 16. Little a is 13. Clearly not enough. I drink way too much coffee. I'm loving it. So, it looks, based on this ridiculous drawing, I've got sine, I got angle A and side A. So let's start with that. 16 over the sine of 40 is equal to 13 over the sine of B. Okay, so if I cross multiply, I get 16 times the sine of B equals, this is me making eye contact with you. It's a little creepy, isn't it? 13 times the sine of 40. I still need to solve for B, so I got to get rid of the 16 first. And then I'll write it as sine B equals, notice I leave a little space, 13 times sine of 40 over 16. Now, you know what I tell my kids? I said, okay, after we've talked about the fact that arc sine and sine, or inverse sine and sine, sort of cancel each other out, or are inverse of each other, so they kind of eliminate each other, I just say, hey, slide that sine over there, we'll make it -1. Change its side. Change its sign when you come over. It's kind of tricky, kind of stupid. Shouldn't really do it that way, but, you know, I think you know what we're doing. We end up with B equals, this one I don't know, so I'm going to have to use my calculator. So the inverse sine of 13 sine 40. So the inverse sine of a fraction, 13 sine 40. 13 times the sine of 40 all over 16. And I end up with 31 point, let's go 31.5. 31.5. Now this is in the first quadrant. I still need to find that angle in the second quadrant. And my reference angle is 31.5. I don't know why I'm using the big one, so the big green. So my other angle that it could possibly be is 180 minus, well, let's just minus the answer. And 140, let's go 149, what the heck, 148.5, whatever. So I still have to make a test. I got to check it out. I got to see what's going on here. Can I make one triangle? So I would start with the 40 that I was given. That's up here and in the problem. Plus 31.5. Well, that's 71. Clearly tons left over for the last one. Not a problem at all. Let's check angle 2. 40 plus 148.5. Ooh, that's pretty close. That's pretty close. Let's see. 148. Did I do this right? Because I thought this one worked out to be two angles. Two triangles. Nope. This is 188.5. So once again, no. So we only get one triangle here too. So let me show you another way they can ask this same question. We already said a few minutes ago that the angles could be all acute or one could be obtuse, or you can have neither. By the way, look at over here. I'll show you real quick. I'm not going to go through all these problems with you, but over here, here's the four different answers that they always give you for these triangles: 0, 1, 2, or 3. Well, yes, it could be 0, it could be 1, and it could be 2, but it can never, ever, ever be 3. Can't make 3 different triangles. You can only have an angle in the first quadrant, maybe sometimes an angle in the second quadrant. You know what? I'm going to have to show you this one because I know this one works out. I'm certain this one works out to 2, and I want you to actually see an example of where it works out to 2. So let me show you this one. I'll go through it rather quickly. If I go too fast, just pause it and come back or rewind it. Okay? So A, B, C, little a is 10, little b is 13, and angle A is 35. So if I do 10 over sine 35 equals 13 over sine B. Cross multiply, I get 10 times sine B equals 13 times sine of 35. Again, I'm going rather quickly. I want to show you that at the end of what's this going to look like when you get 2 triangles. I'm pretty certain this one works out to 2 triangles. So I'm going to do the inverse sine of all this, just to kind of figure out what B is. And I apologize, it's not the greatest work. So let's just do inverse sine of a fraction. And it's 13 sine 35, 13 times the sine of 35 all over 10. And you get 48.2. I'm just going to use 48. It's close enough. So I'm going to now test, and then I'm going to talk about these I'll talk about these possible multiple choice answers with this particular problem. And I'll go back to the first couple. So triangle 1. Can I make one triangle out of it? Well, 35 plus 48. There's tons of extra room for a third angle. And as a matter of fact, let's figure out what it is. 180 minus 35 minus 48 equals 97. So this third angle would be somewhere around 97 degrees. Or triangle 2, I could have 35 degrees plus, okay, wait a second, let's go back to what we're doing over here. It's or, we didn't find the other angle. We did not find the other angle. So 180 minus 48 is 132. So my second angle would be 132. How much is that? Does it leave me more for any left over for a third angle? Well, lo and behold, this adds up to 168. Oops, excuse me. Sorry about that. It's 167. All right. 167. Doesn't that leave me, I still have 180 degrees. That leaves me 13 more degrees, or approximately 13 degrees for that last angle. So yeah, I can make 2 triangles. I can make 1 and I can make 2. So the answer to this question is 2. But sometimes they ask it like this. What kinds of triangles? Well, any triangle that has an angle bigger than 90 degrees, it's obtuse. So in this case, I can make 2 obtuse triangles. I don't think that's a thing. Sometimes it comes out to be acute. Sometimes it only comes out to be obtuse. Sometimes it comes out to be one and the other. Sometimes it comes out to be neither. And sometimes it comes out to just be, like these up here would just be acute. One acute triangle. All right. let's work on this. This is called a multi-step problem, and you'll see why in a second. I was given that PS, I'm going to draw in red because tiny red. I was given that PS is 82. I was given that angle S is 38. I was given that angle 4 is 63 degrees. And I was given that angle 1 is 46 degrees. And angle Q is 79 degrees. Now I'm going to go through and find angle 3. So it's 180 minus 79 and 46. 79 minus 46. Allows me to find that last angle. Okay, this one's 55 degrees. And I can get rid of, I can find out 2 as well. I'll take 180 and subtract off 63 and 38. So 180 minus 63 minus 38. And I get, oh, 79. What? Okay, whatever, 79 degrees. Now my goal and what they're asking for is to find QR. That's this X right here. Well, if I'm going to do that, I need to do X over, and the angle opposite this X is this 46 degree angle here. So sine of 46 equals, now I can either pick this side here or this side here. If I pick this side here, it would be over sine 50, but I don't know this side. And if I pick this side here, it would be over sine 79. I don't know that side. So I can't really do it that way because I don't know this side and I don't know this side. So what you need to do is you need to work in this triangle. You almost indirectly have to get there. So what we're going to do is we're going to assign this center value, y. Now, I'm not working on the left triangle. I'm only working on this triangle off to the right here. Just the right triangle. So if that's true, then y would have to go over sine of 38. And that would equal, let's see what I know. I know 82 over the sine of 63. 82 over the sine of 63. We've done this before. That's just the law of sines. We're just going to cross multiply. We've already done it like 6 times. We're just going to cross multiply. So y times the sine of 63 is equal to 82 times the sine of 38. Well, I'm going to solve for y, divide by the sine of 63, divide by the sine of 63. And I get y equals, who the heck knows, 82 sine 38, 82 times the sine of 38 divided by the sine of 63 divided by the sine of 63. Now you'll notice it's going to make it a nice fraction. This is exactly what it looked like on my screen. So 56 point, I cannot round now. This is not my final answer. I need this full answer here. So 5665, 5665, 9788, 9788, 2352, 2352. This is going to be used now back in my original question that I thought of. This 56.65 dot dot dot, and that's this y value right here. Well, I'm going to put that over the sine of 79. See, now I was able to get a side that is in the left triangle by finding that middle or shared side, and that's the kind of trick to this thing. Now I'm just going to do the same thing. I'm going to cross multiply one more time. That's all I'm going to do. So x times the sine of 79 equals 56 point blah, 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 blah. You should write that out on the test. Don't be lazy like I am. I'm just trying to save some time. It's late. I'm tired. Times the sine of 46. To solve for x, I'm going to divide by the sine of 79. Divide by 79. Sine of 79. And so I get x equals. So I'm going to take the answer here and I'm going to multiply by oops, enter. I'm going to multiply by, so it's just taking the old answer, and I'm going to multiply by sine of 46. And I'm going to divide by the sine of 79. And I hit enter. And notice it typed it in for me nicely. Makes me, oh yeah, that's what I have. I have that 56 times the sine of 46 all over the sine of 79, and I get 41.52. 41.52, 0489, 0489. I want, oh, it doesn't say, let's say we round to the hundreds place, x equals 41.52. And that's how you find these. That's how you do the complex ones. Let me show you in like a more real life example, because this is another thing that you could do. You could stand on the ground and measure this angle here and see how high it is to the top of the building. Walk a certain distance away, measure that same angle, and with just that information, you can find the height of the building. But the trick is knowing a few things. First of all, you're going to have to know that this is 114. It's 180 minus 66. And then you're going to have to find this angle up here, which is really 180 minus the 114. Minus, I think it was 39, minus 39 equals 27. So now I found that 27 degrees. Why am I doing this? Because I don't have enough information in this small right triangle over here. I want to find the height of this building. That's my goal, is to find x. I cannot find x directly, so what I'm going to try to do is find y. Y would then get me into this triangle off to the left. If I don't know why, I just don't have enough information to find x. I need some more information. So let's see. Y is opposite the sine of 39. So y over the sine of 39 equals, let's see, I want y over 39. And the only thing I have is this 43 opposite of this sine of 27. 43 over the sine of 27. All right. I'm just going to cross multiply. I get y times the sine of 27 equals 43 times the sine of 39. Divide by the sine of 27. Divide by the sine of 27. Don't round. You cannot round to the very end. It is brutal to sit in a classroom and see kids round at the wrong time. You round only at the end. So 43 times the sine of 39 divided by the sine of 27. And we get 59.606, 59.606, 4825, 4825, 821. All right, so let me clear up a little bit and see what we got here. I now have that this is this 59 point something. Well, I just did a law of sines again. This 59 is opposite the 90 degree angle here. So this 59.606 repeating, not repeating, but going on forever, all over sine of 90 is equal to x, my side x, over the sine of 66. Cross multiply, I get x times the sine of 90 is equal to this 59.6 times the sine of 66. Well, let me ask you this question. What's the sine of 90? Isn't it just 1? So that really just gives me x. So really my final answer going to be is this 59 point something times the sine of 66. So when I go over here, I'll just hit times sine of 66. There it is, 54.45, 5445 Around the nearest meter. Okay, x equals 54 meters. So here's what I'm going to do. We're going to do one more of each problem. One more of each problem. I'm going to find one more to do of every problem. Let's see. So 13, we're going to find a length of a side. Let's see. I'm going to need this because it's opposite of 12. So 23 and we'll put the 3 there. That's 80. So this is 100. So I'm just going to find B. So 12 over the sine of 100. And I got that 100 because 3 angles of a triangle add up to 100 degrees, 180 degrees, is equal to B over the sine of 57. And then if I cross multiply, I get B times the sine of 100 equals 12 times the sine of 57. Divide by sine of 100, divide by the sine of 100. Put this, all of this, in my calculator. 12 times sine 57 divided by the sine of 100. And I get 10.219. X equals, not X, B equals 10.219, 309. 309. And I said nearest hundredths place, that's 2 decimals, it's right here. So the answer is B equals 10.22. Boom. So one method or one area where you can use, or one thing you can use the law of sines for is to find a missing side. That's one. The other one would be to see how many triangles I can make. I think I've done that one already. Let's try another one. Let's do this one. It's a little bit different. A, B, C. I didn't tell you angle A. Oh, this is angle A. So angle A is 65. A is 24. Little b is 25. And we need to find capital B, angle B. So 25 over the sine of B is equal to 24 over the sine of 65. Okay. So let's see, 24 times the sine of B is equal to 25 times the sine of 65. Divide by 24, divide by 24, and I get sine of B is equal to, now I'll leave a little space because I know I'm going to be looking for an angle, and the only way to find an angle is to use inverse trig functions. Uh-oh, running out of memory on this thing. Divided by 24. So I'm going to bring this sine over, make it -1. And I get B equals, now I'm going to have to do the inverse sine of this. So that's 25 times the sine of 65 divided by, make sure it looks like this when I'm done. Make sure it looks like this. Oh yeah, there it is. It looks just like what I have written there. Oh wait, hold on. I forgot something. I needed to do the inverse sine of this. Enter. I need to do the inverse sine of this. What am I doing? So control sine, inverse sine of, I guess I'm going to do it this way. And I do that, and I go, oh, 70.7 degrees. Sorry, that was a little weird. 70.7. That means, and that's like 71. So my other one would be like 109, 109 degrees. So I got to go back. I can go, triangle 1 could be 65, 71, and yeah, there's plenty left over for another one. Or I can go 65, 109. That's like, ooh, that's close. That's 174 degrees. 174 degrees. But that leaves me 6 degrees left over. So it looks like it's going to be, oh wait, I got to tell what kind of triangle this is. This is clearly an obtuse triangle. This is 136-ish, so that leaves me like about 40 left over for this. So that means that I can do it both an acute and an obtuse triangle. All right, let me give him one more complicated problem. I hate those questions. Let me do a fun one. Yeah, let's do this one. This one's kind of interesting. Yeah, right. So, all right. So let's see. I know that KL is 100. And then I measured these things. I can't go across the river. I mean, here's a clear example. I cannot go across the river. So I'm going to use some instruments and some tools to figure out what is the width of this river. I mean, it got to be something I can do. So it says that JKM is 41 degrees 40 minutes. And it says that this little angle here is 38:20. 38 degrees 20 minutes. Now, if I remember correctly, I need to find some missing angles. I think I can find this one. So I'll just take 180 and subtract that. 180 minus 4140. 4140. And I get, oh, you stupid thing. I forgot about this calculator. You got to put a decimal in. And then it's just going to give you some decimal. And I'm going to have to DMS this anyway. So let's DMS it. And 138.20. Let's go 138.20. 138 degrees 20 minutes. But that's not going to help. I really need this angle. So I'm going to take that 138.20. I'm going to add 38.20. 38.20. And I'm going to hit enter. And I'm going to take 180 and subtract off that answer. And I'll DMS that. It's going to be some low little angle. 3 degrees, 20 minutes. 3 degrees, 20 minutes. I should have just gotten rid of the degrees. All right, so now I'm ready. I can do 100 over the sine of 3 degrees, 20 minutes is equal to, now what I'm going to find now, what I'm looking for is this right here, this y. Remember I told you we want to find the middle value between the two sides of the two triangles. So we're going to find y, and y is opposite 38 degrees, 20 minutes. So it's a complicated problem. All I had to do was find the other little angles and then just start working with it. Not a problem. So I'm going to do y times sine of 3 degrees, 20 minutes. Now, this should be a pretty big number. It's a river. Oops, equals, 100 times the sine. Oops, I forgot the word sine down here. That's kind of silly. Sine of 38 degrees, 20 minutes. And I'll divide by the sine of 3 degrees, 20 minutes. Wow, got a lot going on here. So 100 times the sine of 38.20, 38 degrees, 20 minutes, divided by the sine of 320, right? 3 degrees, 20 minutes. 3 degrees, 20 minutes. And I get 1,066.7. Now this I can't round. So 1,066.7, 0791, 348. Well, let me get rid of a few things. Well, I got y now. I've got this right here. I've already got this. And I want to find this river length, width, x. Well, x has to go over 4140. So x has to go over the sine of 41 degrees, 40 minutes. Sorry, I haven't looked up in a while. You're probably all toned out on me already. Is equal to this value. I'm not going to write this because this is my last problem. This value over the sine of 90 degrees. So what I finally end up with when after all is said and done, we're going back to red, is x times the sine of 90, but isn't the sine of 90 really just 1? Is equal to this 1066 point blah, 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 times the sine of 41 degrees, 40 minutes. So I'm going to take this and multiply by the sine, and I got to go 4120. 4120. And my final answer is 704. So x equals 704.495. And to the nearest meter, the answer is 704. Wow, that was a lot of work for that problem. All right, if you guys hung in there all the way till the end, kudos to you. Nice job. Great job working. Hopefully you understand a little bit about the law of sines and how it's used and how it's utilized. That's kind of a crazy problem, but that's not unrealistic than what you're going to see on that Regents exam. So, peace out. Nice job. Adios, amigos. Gotta hit the right buttons. Goodbye. Goodbye.